previous video, we learned how to graph sine and cosine with different amplitude and periods. In this video, we extend that lesson by including phase shift and vertical shift. Join me for PreCalculus Online now. In section 6.6, we look at the graphs of sine and cosine with phase and vertical shifts. So the general formula here of a sinusoid is y equals a sine of omega x minus phi plus d. And so the new Greek letter here is phi, and I normally draw it like that, maybe a little more closed sometimes, something like this. And the key to working with these is to, first of all, rewrite the interior. So we're going to get y is equal to a times the sine of, and basically we want to factor out the omega. That's going to leave us with omega times x minus phi over omega, and then plus d on the end. And you can verify that if you redistribute the omega, you do get what was in the original equation. What this allows us to do is to see the pieces that we need to graph a sinusoid sort of in their different parts. So, as usual, we have the absolute value of the a being the amplitude of the sinusoid. The omega is not the period, but it is the number that gives the period. And we know that t is equal to 2 pi divided by omega. Now, from college algebra, you probably studied the horizontal stretch and compression number. That's what the omega is doing for us here. Horizontal stretch and compression. Next, we look at this whole number as one thing, this phi divided by omega. That is the phase shift. And the rules for phase shift apply just like they applied for horizontal shift from college algebra. If it's minus that number inside, then it's to the right. If it is plus that number on the inside, then it's to the left. Finally, we have the d, which is just the vertical shift. Let's look at example 1. Graph y equals 4 sine of 3x minus pi. So our first step is to rewrite it as y equals 4 sine of, factor out the 3 times x minus pi over 3, and there is no vertical shift in this one, so I'll just say plus 0 for emphasis. So step 1, isolate all these values. So the amplitude is going to be equal to 4. Step 2, the period is going to be 2 pi divided by 3. And the phase shift is going to be, from this number right here, pi over 3 to the right. Now, how do we graph this? Well, what we want to do is we want to start our sinusoid where the phase shift tells us to start it. Sine normally starts at 0, 0. We're going to move that over to pi over 3, according to the phase shift. Next, I want to sort of plan out where the graph goes. So I want to look at what one period of this graph is going to look like. Well, we know that one period is 2 pi over 3. In other words, it has a distance that goes over to the right, 2 pi over 3. So if we're going to start at pi over 3, and then we're going to shift over 2 pi, the ending point for the period must be the sum of pi over 3 and 2 pi over 3, which is just pi. So I know I want to start at pi over 3 and end at pi. Finally, I want to look at the spacing. Some text, and our text does this, calls this the key points. How far apart are these key points? Well, we know that we can break up a sinusoid into fourths. There's the part where it goes up to the max, and then it goes from the max down to the median, from the median down to the minimum, and then from the minimum back up to the median. What is the distance between each of those key points and the lengths of those particular segments? Well, if we just take 1/4 of the period length, that would be 1/4 of 2 pi over 3. If you simplify that, you get pi over 6. So each of these main points, the median, the max, and all of these, they have to occur at regular intervals of pi over 6. So now I want to graph the sinusoid with this information. I notice that I have a pi over 6 as sort of our main spacing number. I'm going to use that number for the tick marks along the base here. So this would be pi over 6. Going over another pi over 6 would be 2 pi over 6, but that reduces to pi over 3. Another one would be 3 pi over 6, but that reduces to pi over 2. 4 pi over 6 is actually 2 pi over 3. 5 pi over 6, and then 6 pi over 6 is pi. And let's start with that and see what we can do. I'm going to graph it in purple. And what you can't see anymore behind the pin block here is that it starts at pi over 3. There was no vertical shift, so we're starting at 0, a y value of 0. We know that one period goes over to pi. And then we know that each of the marks that we've put on this graph is exactly the spacing for where the max and the min occur. So let's go ahead and mark this as 4, and this is -4. And as we go to the right, we're going to go up to the max, back to the median, down to the min, and back to the median. That's one period. We always want 2 periods. So now I'm going to go backwards. We're going to get pi over 6. We're going to get 0 going back another one. I need to make some more tick marks here. So let's have negative pi over 6 and negative pi over 3. We should have the maximum and then the median again. And now let me connect the dots in a sinusoid. And there's our graph. Let's look at example 2. Graph y equals 2 cosine of 2x minus pi over 2 plus 1. So everything that we did for sine on the first page applies to the cosine graph with the shifts, the vertical shift, the phase shift, etc. You just have to remember that the cosine graph starts at 1 instead of 0, but everything else is the same. So first, let's rewrite this. Factor out the 2 from the inside here. Pi over 2 divided by 2 is pi over 4. The amplitude is going to be 2. The period is going to be 2 pi divided by 2, which is just pi. And that 2 was this one. The phase shift is is going to be pi over 4 to the right. And we do have a vertical shift of 1 up. So that's going to change where the median is. So now I want to start at pi over 4, analyze one period. It's going to start at pi over 4 and go over pi, which is 5 pi over 4. Next, my spacing would be 1/4 of the period length, which is pi. So that would just be pi over 4. So I look for the smallest fraction to use here, and that would be the pi over 4. Now let me draw the grid. The first thing I want to draw is the median. The median is at 1. So this green line serves as the median. Next, we know that the maximum is going to be at 3, and the minimum is going to be at -1. So we'll go ahead and put those in. Then let's put in some tick marks here. And we start with pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and then let's go backwards. Negative pi over 4, negative pi over 2. Let's see if that's going to be enough. If not, we'll add some more. So this time, I'll make it in dark blue. So this is the cosine graph. So it's going to start at the maximum when the x's is pi over 4. Then it goes down to the median, then down to the minimum, back up to the median, and then back up to the maximum. And then it does the same thing, but going in reverse here. So we're going to have the median, the minimum, the median. Looks like I'm going to need one more point. I'll put that one right here. And then you connect this to form the sinusoid. Looks good. Let's look at example 3. Graph y equals sine of pi minus pi x. This one needs some severe rewriting. So first off, let me rewrite this with the x in the first position instead of the second position. Then I see that the x is being multiplied by negative pi. So I want to factor that out. That gives me sine of negative pi times x, and then be careful because there was a negative factored out. This becomes -1. Again, this is one of those things that you can check by distributing the negative pi back into the expression to see if you get the original part. Next, we have a negative on the inside. With sine and cosine, you can get rid of those using the odd and even functions. Since sine is odd, the negative comes out to the front. With cosine, it would just go away because cosine is even. But sine is odd, so it comes out to the front. All right, now we're looking good. The amplitude is going to be the absolute value of -1, which is 1. The t, the period, is going to be 2 pi divided by this pi right here, which is going to be 2. Now notice that since there's pi inside the equation itself, then there is no pi in the period. A lot of times scientists will use this if there's a measurement of time that is needed for the x-axis, like 1 second or 2 seconds. And that's what this period represents here, maybe. It could be 2 seconds instead of the sort of awkward to use 2 pi seconds or something like this. Next, we have a phase shift. Phase shift is 1. Again, that would probably be like 1 second, something like that, to the right. And the vertical shift, there is none, so that's a 0. So where are we going to start? Well, we start at 1. We look at the 1 period distance. 1 period is going to start at 1, and then the end point will be 2 more, because 2 is the period from 1, so that's 3. Finally, we want to look at spacing. It's going to be 1/4 of the period length of 2, which is a half. So let's make the graph. One, 2, 3, 4, 5, -1, going back that way. Let's mark off the median, the max, the min, etc. The phase shift is 1 to the right, and we're dealing with sine, so we're going to start at the median at 1. Now, normally, we would go up to the maximum, but because we have the negative in front, you can still barely see on the screen here, then that means we have a reflection. So we have to go down to the minimum, and it's going to be a minimum of -1. And that gives us the rest of the pattern. So the maxes and the mins occur at these half points. And then we get zeros every place else. And then let's connect that. Like so. Next, we look at sinusoidal modeling. So basically, we have phenomena in the real world that varies in an up and down fashion, and it repeats on a certain regular interval called the period, and we use a sine function to model that phenomena. You could also use a cosine function, but we basically just use the sine function. Let's look at example 4. The average high temperature in Austin reaches a maximum for the year of 96 degrees Fahrenheit in July and a minimum for the year of 60 degrees Fahrenheit in January. Create a sinusoidal function to model the average high temperature based on the month of the year. So to do this, we need to find all the aspects: the amplitude, the period, the phase shift, and the vertical shift. So let me start by detailing some of the information that we have. We know that the maximum value reached is a 96, and we know that the minimum value reached is a 60. In order to get the median has to be the average of these two values. So I'll take the average. So the median is equal to 96 plus 60 divided by 2, and that's going to be 78 degrees. Next, I want the amplitude. The amplitude is how far the max is from the median. So I'll just take the maximum value, 96, minus the median value of 78, and get 18. So now we have the median, which corresponds to the vertical shift. Should probably mention that. And the amplitude, 18. Next, we can't really work with the months as their names, January, February, March, stuff like that. We have to assign numbers so that we can do the algebra and work out the model. So what number system should we use for the months? Well, we use the one that's fairly obvious. January is going to be represented by a 1. February is going to be represented by a 2, etc. December is going to be represented by a 12. And then we'll allow the numbers to continue going forward. So 13 would then be January again, 14 would be February again, but in the next year, and it just continues on like that. So we're going to use these numbers for the months. We have the period, and the question is, how often will this cycle repeat on itself? And it repeats every year. We're basing everything on 12 months. So we're going to say that the period is 12. Now I can use this and the formula that is period is equal to 2 pi divided by omega to solve for omega to use in the equation. So if I just do a little switcheroo here, omega multiplies to the top and 12 multiplies to the bottom, you're going to get omega is equal to 2 pi divided by 12, which is pi over 6. So far, so good. Our final question that we need to answer is, what is the phase shift? In other words, if we're going to use the sine function, we know that it has to start at the median, at the point where we have the phase shift number. But it's a little bit more than that. It has to start at the median and it has to rise immediately after. Remember that the sine function is going to hit the median multiple times. So we do have to nail down which one is it. Which one hits the median and is rising at that point. Well, if we sort of look at the data, we know that we have a minimum value in January. We have a maximum value in July. And July is the 7th month. And so if it's going to go from, let me just draw a little sketch here. It's going to go from January, which is the first month, up to July, which is the 7th month. It's going to hit the median, be in the middle, during what month? So what month is exactly halfway between January and July? And the answer is April. Now, you may not realize that right off the bat. You may have to think about it. There's actually an easier way. We know that if the minimum occurs at 1 and the maximum occurs at 7, this median has to occur at the number that is halfway between those. So if I just take the average, 1 plus 7 divided by 2, you get 4, which is April. But 4 is the number that we really want to use here, since it's going to go in the model as the number. All right. We can graph this now if we want to. So I'm going to do a graph that looks like this. And we're not going to start at 0 for the y-axis. We'll start put in some of these numbers here. We have the median. The median is at 78. There it is. And we're going to have the minimum, which is going to be 60 in January. And then we'll have the maximum, which is 96 in July, month 7. We have a median in month 4. And in which other month will we also have a median? Well, the distance between these key points is 3 months. 3 months is a quarter of a year. And so the next month is the 10th month, October. And so let me graph this. And it's still going down at this 12th month because it doesn't hit the minimum until it gets down to 1 the first month, or on the other side, 13. So 1 period should be sufficient here. It looks a little odd because it's not quite centered. That's okay. Now, let's figure out what the model should be. So the model should be y is equal to the amplitude number, 18, times sine of, and then the omega number is going to be pi over 6 times x minus the phase shift, 4, close the parenthesis, plus the median number, the vertical shift, of 48. Let's go ahead and take a look at this on the TI calculator now. Go ahead and enter that on your calculator so you can practice seeing this. And also remember that your calculator has to be in radians to do these types of problems. Degrees will not work for these type of problems. Let's take a look at example 5. The cars on a Ferris wheel reach a maximum height above ground of 42 feet and a minimum height above ground of 2 feet. Jim starts at the lowest car when the ride begins. The wheel makes 1 revolution every 60 seconds. A, find the function h of t so that h gives the height above ground of Jim's car after t seconds. So let's draw a little Ferris wheel here. So the height above ground is a maximum of 42 feet, and the minimum above ground is going to be 2 feet. Now, since the car is moving along a circle, then you can think of this as sort of like a unit circle, and the position of the car is given by the angle that it makes relative to something, and so therefore the height of the car can be modeled sinusoidally. So let's figure this out here. Jim's car started here at the bottom. And let's write down what we know. The maximum is going to be 42. The minimum is going to be 2. So with that, I can find the median. The median is the average of the max and the min. So the average of 42 plus 2, 42 and 2, which is 42 plus 2 over 2, is 22. So this height here, the middle of the circle, is 22 feet above the ground. Now using that information, I can find the radius of the wheel. The radius of the wheel turns out to be the amplitude. So the amplitude is equal to 42 minus 22, which is 20. And let's see if that makes sense. If that's 20, then what's the distance from the center down to the bottom? That would be 2, because 22 minus 2 is 20. So that works out great. What is the period of the ride? Well, the ride makes 1 revolution every 60 seconds. So we can make this 60, and let's make sure that we are satisfying the conditions of the problem. We want a function that is h of t, where t is measured in seconds. So yes, had the question said that t needs to be measured in minutes, then we would have set up t to be equal to 1. All right. Since t is equal to 60, we have 2 pi over omega. Do the old switcheroo here. So omega is equal to 2 pi over 60, which is pi over 30. All right. Now let's take a look at our graph, and we'll graph it from what we know. We know that Jim is in the car that starts at the very bottom of the ride, and he's 2 feet above ground. We know that we have this median here in the middle, and we know that after 1 minute, 60 seconds, the ride returns to the bottom. Jim's car returns to the bottom because it makes 1 revolution every 60 seconds. Since the period is 60, I can figure out these intervals where the key points occur by taking 1/4 of 60 and getting 15 seconds. So let me go ahead and mark off every 15 seconds. And so the car should return to the median, which is halfway up the ride. After 15 seconds, it should reach the maximum of 42 seconds after 42 feet after 30 seconds, and it should reach the median again after 45 seconds. We can extend this. 75 seconds, 90 seconds, like so. And this gives us a portrait of Jim's position above ground, his height above ground, after so long in the ride. Let's use that to make the model. So the model is going to be h of t, that's the name of the function, is equal to the amplitude, which is 20, times sine of omega, which was pi over 30, times x minus, and what was the phase shift? Well, to find the phase shift, let's look back at the graph, and where was the median that was where the curve was on the rise? And that occurs right here at 15 seconds. So this is x minus 15 plus the vertical shift of 22. Question B. How high above ground is Jim after 38 seconds? So 38 seconds, that's a t-value. So we're looking for h of 32. And we can have 20 times sine of pi over 30 times 38 minus 15 plus 22. Be sure and have your calculator in radians and work this out to 2 decimal places. You get 15.38 feet.